Good morning, students. Today we are discuss about the topic is Norton's theorem. Previous class already we can done in Thevenin's theorem. Okay. In Thevenin's theorem, the complex network connected in series with resistance and load resistance. Okay. The Norton's theorem statement is any linear electrical network or complex circuit with current and voltage sources can be replaced by an equivalent circuit containing a single independent current source IN Norton's current and parallel resistance RN Norton's resistance. Okay, in parallel with load resistance also. Okay, Norton's equivalent circuit shown in a linear network containing several energy sources and a resistance. N numbers of resistance are connected in series and parallel. Both connections are there. Finally, we are joined the load resistance. This is the equivalent circuit of the Norton's theorem. Okay, Norton's theorem also having step-by-step procedure, step-by-step analysis. We can done these 6 steps. We can find out how much amount of load current flowing through the load resistance, and then what is the Norton's current. Likewise, we can analyze. First step is short circuit the load resistor. Short circuit the load resistance. Compared with Thevenin's theorem, open circuit the load resistance, we can find out the open circuit voltage. Here, short circuit the load resistor, calculate the short circuit current. That current is called Norton's current. Okay. Third step is open current source. We having current and voltage source in a network. So if we have current source means open the current source. If having voltage source means short circuit the voltage source and open load resistor. We have only voltage source means we can short circuit the voltage source, then open the load resistance. Or we have both current source and voltage source means open the current source and short circuit the voltage source, then open circuited to the load resistor. Then after completing step 3, we can calculate the open circuit resistance. This resistance is called Norton's resistance. Okay, now redraw the circuit, measured short circuit current, Norton's current, or Norton's resistance. We can draw the equivalent resistance with the Norton's current with Norton's resistance followed by load resistance. This is the 5th step. Okay, now easily to understand by using this solved example. In our example, they are providing find RN IN, the current flowing through and load voltage across the load resistors in figure 1 by using Norton's theorem. In this problem, we having 4 resistance. One is load resistance. That load resistance connected between the point A and B, 1.5 ohm. Okay, first step. What is the first step? Short circuit the load resistor. So remove the load resistor, then short circuit between that point A and B. Now we can calculate the short circuit current. Before that, we can find out the equivalent resistance from these 3 resistance, 2 ohm and 3 ohm and 6 ohm. So 2 ohm resistance in series with the parallel combination of 6 ohm and 3 ohm resistance. So the final total resistance is between these resistance on 4 ohm. Now we can find out total current flow, IT equal to V by RT. So 12 volt divided by 4 ohm. The total current flowing from source, 12 volt source, equal to 3 ampere. That IT current is divided to Norton's current. How it is divided? Okay, so ISC equal to IN, Norton's current, equal to what is the actual current flow in that resistance in the short circuit. So now we know the current division rule. Total current into opposite resistance divided by total resistance. Opposite resistance divided by total resistance. Here the opposite resistance for load resistor is 6 ohm, right? So 3 ampere total current IT equal to 3 ampere. Opposite resistance is 6 ohm. Total resistance is 3 plus 6 because the current flow from 3 ampere to 3 ohm resistor through short circuit current. So here 3 plus 6 opposite resistance divided by total resistance. So 2 ampere is a short circuit current. That current is called Norton's current. So now we can find out that current value by using this formula. Next, step 3. Step 3 is short circuit the if connected in that network by current or voltage source. We can check here voltage source are connected, so short circuit the voltage source, remove the open the load resistance. So now we can calculate what is the open circuit resistance, that is open circuit resistance. So 3 ohm 3 ohm resistor in parallel with 6 and 2 ohm resistance. 6 and 2 ohm resistors. Now we can see in the open circuit point. Open circuit point we can analyze the current flow. So current flow through A point to short circuit period. So 3 ohm resistor passing the total current divided to 6 ohm and 2 ohm resistor. So the opposite resistance the total resistance equal to actually parallel with 3 ohm resistor in series, parallel with 2 and 6 ohm resistor. The net resistance is 4.5 ohm. So we now we can the final formula of IL equal to IN into RN divided by RN plus RL, because that is opposite resistance divided by total resistance. This is from the current division rule. Now we can find out IN and RN also. All the values are known values now. So total current 2 ampere into 4.5 divided by actual total resistance. The actual load current is 1.5 ampere. 1.5 ampere. In our problem they are asking voltage across the load resistor. We know the current and resistance value of load resistance, so easily to find out voltage. V equal to I into R by using Ohm's law. So VL equal to IL into RL. So we know the value of IL into RL. So VL equal to 2.25 volt. This is the final statement. So let's see. Remember, compulsory we remember this procedure of Norton's theorem and Thevenin's theorem, mesh analysis and nodal analysis. So total formulate procedure we can well known, means easily to solve the problem. Okay, thank you.